All right, so we've looked at circles and we've seen the equation of a circle. So I want to look at a specific circle for a minute and introduce an idea called transformations. We're going to look at transformations of an equation. In particular, we're going to look at shifting the graph of an equation vertically and horizontally, as well as stretching it or scaling it vertically and horizontally. So to start with, let's take the circle equation we learned and simplify it down to the simplest possible circle. So here I have x squared, which you can think of that as just like x minus 0 squared, right? Which is giving me x squared. And here I have y squared, so that's like having y minus 0. So remember that we're supposed to have x minus h and y minus k, where hk is the coordinates of the center. Since those are both 0, this circle is centered at the origin. The other number I have over on the right side here is r squared, which is 1 in this case. So the square root of 1 is 1. That means this is a circle of radius 1. This is the simplest possible circle you could think of. It's a circle of radius 1 whose center is at the origin, and this is called the unit circle. Let's put a label on this thing. This is called the unit circle. It's a special name for it. We're going to deal with the unit circle a lot in this class later on, especially. But for now, I want to take this unit circle and talk about shifting it around. What if I, instead of having a minus 0 here, what if I put like a minus 1? What that does is it shifts this circle over to the right by 1 unit. If I made this a minus 2, it would shift it to the right by 2 units. If I put minus h and then make Desmos do a slider for h, I can adjust the value of h. And you can really see that shifting. As I increase the value of h, you see it moving to the right. So whatever number is being subtracted from x is the distance which this thing is shifted to the right. That means if I subtract a negative number, and which would be actually adding to x, then I'm shifting to the left. Okay, so remember that. Whatever you subtract from x is an amount by which this graph is being shifted. This property or this behavior is not just for unit circles. This is for any graph. So you could take another graph, like here's the graph of y equals x squared, a nice simple little parabola. If I subtract 2 from the x directly from x, okay, right inside here, I need to introduce some parentheses and do the subtraction, like subtract 2. What I've just done is shifted this graph 2 units to the right. I can do a minus h here, and you can see me shifting this graph sideways, back the other way. So that's shifting. That's horizontal shifting. If I do the same thing with y, let's put a y minus k there, and then add a slider for k. Flip down next, make h first and k second. Then now I can, not only can I shift it left and right with the h value, I can shift it up and down with the k value. So that says whatever number is being subtracted from y is telling you how much this thing is being shifted vertically. All right, go back here to my parabola, and I could do the same thing with the parabola. If I take this y and I subtract k, grab our k value slider, then I can shift this thing up and down vertically. So I'm changing the position of in this case of the circle, I'm changing the position of the center. In the case of the parabola, I'm changing the position of what's called the vertex. You may remember the vertex of a parabola is this point right here. And you can grab that and pull it around. It's the point hk. Okay, it's normally at 0, 0. But if you add these, if you subtract numbers from x and y, then you get the vertex in a different point. So what we're dealing with here are horizontal and vertical shifts, right? And any equation you take, if you subtract from x or subtract from y, you can shift it horizontally and vertically. So next, let's look at another idea. Another screen here. Let's get that back to that unit circle. Here's my unit circle. Instead of subtracting number from x and y, let's try getting in here and multiplying. What if I multiply x by 2? Whoa, what just happened? This no longer is a circle. This is now an ellipse. An ellipse is the sort of mathematical exact word for a particular type of oval. So if I multiplied that x by 2, what happened was, let's it was like this, multiplied x by 2, and it went like that. So now you can see these points here are actually at negative and positive 1/2. What happened was we just took this circle and squished it horizontally, in the horizontal direction. We squished it and made it half as big. Okay, if I multiply x by 3, then we squish it and make it 1/3 as big, right? So it's like we're really doing a scaling. Scaling is where you multiply the width or the height of something. And here we're scaling it horizontally, not by 3, but by 1/3. So really what it's more like we did is we divided by 1/3. Divide by 1/3, you scale by 1/3. So what happens if we divide by another number? If we divide by 1, nothing happens because you're scaling by 1. What if you divide by 2? Then you stretch it. You're scaling it by 2. And since we divided x by 2, you're stretching it out by a factor of 2. Okay, this is not that different from the shifting. If we wanted to move it horizontally 2 units, okay, let's go back to zeros. If we wanted to move it horizontally 2 units, what you do is you don't add the 2 to the x. You subtract 2 to the x. It's like you do the opposite, because then x has to accommodate that by being 2 units bigger. So you shift it to the right by subtracting, which is kind of the opposite of what you might expect. Similar with scaling. With scaling, we're going to double the width by dividing x by 2. That way x has to be twice as big to accommodate that division by 2 factor that's in there. So you could do this with y as well. If we wanted to scale this vertically in the y direction, just take the y, and divide that by something. So if I divide by 3, now I have made it 3 times as tall. So now it goes out to 3 and -3 in those directions. So this idea of scaling your shape, your circle in the vertical and horizontal directions produces ellipses, either tall, skinny ones, or we could have like long, thin ones. That's going to be the first way that we approach looking at ellipses, by the idea of scaling. Now you can combine that together with the idea of shifting. So if I get in here and then say, after scaling, oh, by the way, we're going to use some numbers here. We're going to use A and B to represent the amount of scaling we have in the x and y directions. There's our A and our B, okay? So A is now looks like the horizontal, A is the horizontal scaling factor, which is kind of the horizontal radius in a way, and B is the vertical scaling factor. And now if I take this and go in and do my subtract h and subtract k, now I can also combine that scaling with the shifting and produce an ellipse, any ellipse centered in any location with any shape, dimensions that you want. And that's all just by doing these things called transformations. 2 types of transformations, shifting and scaling. So that's the end of this video. The next video I'm going to get on paper and show you what it looks like, what ellipse equations look like on paper.